Hi guys. So we were discussing about work. Work is defined as the product of force and displacement. So we will represent force as F bar and displacement as D. Force is a vector and displacement is also a vector. So to define work, the force and displacement should be in the same direction. That can be known as positive work. The units of work, Newton meters, so that is also called joules. If there is no displacement, if you apply force on an object which is not displacing, then the work done equal to 0. To define work, object should be displaced. If object is not displacing, just like at here, if you apply force on a solid rock which is not moving, then the work equal to 0. So in this case, the work, if object is not moving, if it is moving, then we can say that the work has been done. So to define work, suppose if object displacement, this cart is moving forward at a displacement of 6 meters, then what is the work done by the cart? So here the work done by the cart equal to 0. Why? Because the cart is applying force perpendicular to the displacement. When force is perpendicular to the displacement, the work done equal to 0. Because the displacement at here we will take as the angle between them equal to 0. So there we can say the work done equal to 0. Suppose if force direction and displacement direction, and they both are in the same direction, then we can say that the work is done. So likely we define work. So today I am going to talk about energy. So energy is nothing but whenever we think about energy, so we will think about this. The energy needed to do work. So if you consume then good food, then we can get good energy. Other than that, we will think about energy source. Your sun is an energy source because we can get much more energy from the sun. So if you have more energy, so that help us to do more work. So more energy leads to more work. Now, if more work, to do more work, we need more energy. If our energy levels are less, we cannot do more work. But in physics, the energy we define in another way. The energy in physics are two types. One is kinetic energy, another one is potential energy. So what is kinetic energy? So observe this carefully. A moving ball, a ball which is moving, is the reason to take off the stumps. So the energy due to motion of the object. If an object is moving due to the motion, the energy that is known as kinetic energy. And one more energy we can define potential energy. So potential energy due to because of the position. So highly raised hammer, the highly raised hammer is used to nail. So here the energy comes due to because of the height of the hammer. So that is known as potential energy. So we define in physics energy two ways: kinetic energy and potential energy. And potential energy is another way, the energy which is stored in this key toy. We know that the key toys are having a spring which is rolled, a rolling spring. The springs also stores energy in the form of potential energy. So energies are the two ways. One is kinetic energy. So kinetic energy and potential energy. So the kinetic energy is due to the motion of the object, here the moving ball, either the moving ball or a moving truck. So the moving ball is having the energy, so that energy is taken out the stumps. So one more energy known as potential energy. So potential energy is due to the position. So here the hammer which is striking, that is the position of the hammer. If you want to hit a nail, we have to hit with the hammer with more force. Now here the hammer is having potential energy. So let's talk about kinetic energy. So remember carefully, kinetic energy is only an object which is moving. Those objects possesses kinetic energy. Let's define kinetic energy. Kinetic energy is the energy of an object because it is moving. So how to increase the kinetic energy? If the mass is more, then the object kinetic energy is more. So if the velocity is more, then the object kinetic energy is more. So kinetic energy is due to because of the motion of the object. So we can define its formula: kinetic energy equal to half mv square. The kinetic energy, we can write a formula half mv square. Here m is mass of the object and v is the velocity. So this formula, please remember, kinetic energy equal to half mv square. To increase the kinetic energy, just increase the mass, or if you increase the velocity, then the object kinetic energy also increases. So let us try to derive an equation, how this formula come up. So now I am going to derive the kinetic energy of an object. So moving object possesses kinetic energy. So kinetic energy is, I can represent kinetic energy as k dot E. Kinetic energy is due to motion of the object. So let me derive the kinetic energy expressions. So to derive kinetic energy expressions, I need to recall this formula first. What is the work formula? Work equal to product of force times displacement. And from Newton's second law, what is the force formula? Force F equal to ma. Not only that, we can use at here third equation of motion, that is v square minus u square equal to 2as. So please recall these three formulas. So consider I am having a car of mass m. Now it's moving. So it is moving, it's due to some force. So according to Newton's second law, what is the force acting on the car? That is F equal to ma. Force equal to mass times acceleration. So that is equation 1. And we know that We know that work formula, work equal to, work we can define as W equal to the product of force times displacement. So I know what is the force value from the first equation. I can substitute at here the first equation's value at here. The force equal to MA, so it becomes MA times S. Now we need to write the displacement equation S. So from the third equation of motion, we can write V square minus U square equal to 2AS. Now from that we can write that S equal to V square minus U square upon 2A. So what this equation tells? That this equation says about initially the car having initial velocity U. So the car is having initial velocity U. Then after some times it's accelerated with an acceleration A, and its a final velocity becomes V. Now by writing V square minus U square equal to 2AS, let's substitute this. You can call equation 2 in equation A. I can substitute 2 in equation A. So how this equation changes? Work equal to MA of V square minus U square upon 2A. Now here A gets cancelled on the numerator and denominator. So which is left over? So the work equal to, if you can write that, half, I will write 1/2 ahead, half times M times V square minus U square. Now let's multiply this. W equal to half M V square minus half M U square. Now we know that kinetic energy formula, kinetic energy equal to half M V square. So this term we call as kinetic energy final, because V is known as final velocity. And another term, this term we call it as kinetic energy initial. So this expression will be changes. W equal to kinetic energy, I will suffix write final, minus kinetic energy initial. Now if you can see this formula as a new formula for work. What is this? The work, another formula here equal to change in kinetic energy. So this is another formula for work. Kinetic energy final minus kinetic energy initial, which is also called as work. New formula for work. So work equal to kinetic energy final minus kinetic energy initial. So this is the new formula, and we know one more formula for work. So the work equal to the product of force times displacement. So these are the two new formulas. Now come back at here. Suppose if the car is at rest, initial velocity. If car is at rest initially, that is its initial velocity its initial velocity value becomes u equal to 0. If initially the car is at rest, we can take that initial velocity equal to 0. By the time this formula will be changes, if you can substitute this at here, this formula will be changes as the work W equal to half mv square, which equal to kinetic energy final. So which is the formula for kinetic energy? So this is the simple formula for kinetic energy. So here we got two formulas. So that two formulas, one is formula for kinetic energy and one more formula, here it is, the work, another formula is change in kinetic energy. So the work equal to one more formula here for work equal to change in kinetic energy final minus kinetic energy initial, which also known as change in kinetic energy. Please remember that. So work equal to change in kinetic energy. And here one more point I can say at here, if you remember, if you see this formula, work equal to half mv square. So this we call as work and this is called as kinetic energy. So what the equality symbol says? The equality symbol says at here work equal to energy. So this is another relation. So till now we were thinking work is different, energy is different. It's not like that. The work is nothing but energy. Or common sense we can think, if we have more energy we can do more work. If we have less energy we will do less work. So the work and energy, they both are related. So here you remember the kinetic energy formula, kinetic energy of a moving object equal to half mv square. To derive this kinetic energy we use which already known formulas. Here the known formulas equal to, one is Newton's second law, these three, work equal to force and displacement, and force equal to ma, and third equation of motion v square minus u square equal to 2as.